Our first question is, what is Pytorch Autograd? Pytorch Autograd is an automatic differentiation engine that computes gradients for neural network training. Think of it as a smart calculator that remembers every math operation and can work backwards to find how much each input affected the final result. Remember, Autograd equals automatic plus gradient. It's your AI assistant for calculus. Master Autograd. Master deep learning. Every AI breakthrough starts here. Summary. Autograd automatically computes gradients by remembering operations and working backwards through calculations. Our second question is, how does backpropagation work in Pytorch? Backpropagation traverses the computational graph backwards, applying the chain rule to compute gradients. Like following breadcrumbs backwards through a forest, each step tells you how much that path contributed to where you ended up. Remember, back equals backwards, prop equals propagate. Errors flow backwards to teach the network. Every error is a lesson. Backprop turns mistakes into wisdom. Summary. Backpropagation follows computational graph backwards using chain rule to calculate gradients efficiently. Our third question is, how do you compute gradients in Pytorch? Call backward on the output tensor to trigger gradient computation throughout the graph. It's like pressing a magic button that makes every variable remember how it contributed to the final answer. Remember, backward equals tell me how to improve. It's the learning trigger. One backward call unlocks infinite learning potential. Summary. Call backward method on output tensor to automatically compute all gradients. Our fourth question is, what is the role of backward? Backward initiates the gradient computation process and populates the grad attribute of tensors. Think of backward as the teacher grading your test. It tells you exactly where you went wrong and by how much. Remember, backward equals show me the way. It reveals the path to improvement. Every backward call is a step closer to AI mastery. Summary. Backward method starts gradient computation and fills grad attributes with calculated values. Our fifth question is, how can you stop gradients from flowing? Use detach or torch no grad context manager to stop gradient computation. Like putting a roadblock on a highway, gradients can't pass through, saving memory and computation. Remember, detach equals stop here. Use it to freeze parts of your network. Smart gradient control equals efficient training. You're in charge. Summary. Use detach or no grad to prevent gradient flow for memory efficiency. Our sixth question is, when would you use retain graph equals true? Use retain graph equals true when you need to call backward multiple times on the same computational graph. Like keeping your work notes after an exam, you might need to review them again for a different question. Remember, retain graph equals true means keep the recipe. Useful for multiple loss functions. Flexibility in learning equals power in AI. Master the advanced techniques. Summary. Retain graph true allows multiple backward calls on same computational graph. Our seventh question is, what is the gradient accumulation problem? Gradients accumulate with each backward call, requiring manual zeroing between iterations. Like a bucket that keeps filling with water, you need to empty it before each use, or it overflows. Remember, always zero gradients. Like cleaning your workspace before starting fresh. Clean gradients equals clean learning. Attention to detail makes champions. Summary. Gradients accumulate automatically, requiring manual zeroing between training iterations for accuracy. Our eighth question is, how do you manually set gradients to zero? Use grad 0_ for individual tensors or optimizer 0 grad for all parameters. Like erasing a whiteboard before writing new equations, start fresh for each learning step. Remember, 0_ equals fresh start. Essential for proper training loops. Every reset is a new opportunity. Master the training cycle. Summary. Use grad 0_ or optimizer 0 grad to reset gradients. Our ninth question is, what is the grad fn attribute? Grad fn stores the function that created the tensor, enabling backward pass computation. Like a DNA record of how each tensor was born, it remembers its mathematical parents and operations. Remember, grad fn equals my creation story. It's the computational DNA. Understanding the graph equals understanding intelligence. You're a neural architect. Summary. Grad FN attribute stores creation function enabling automatic backward pass computation. Our 10th question is, how to compute gradients with respect to inputs? Set requires grad equals true on input tensors and call backward on the output. Like asking if I change this input slightly, how much does the output change? Crucial for optimization. Remember, input gradients equal how sensitive is my output? Key for understanding models. Gradients reveal secrets. You're becoming an AI detective. Summary. Set requires grad true on inputs then call backward for sensitivity analysis. Our 11th question is, what is Torch no grad and when to use it? Torch no grad disables gradient computation for operations inside its context, saving memory during inference. Like turning off the recording device when you're just listening, not learning, saves energy and space. Remember, no grad equals just compute, don't learn. Perfect for model evaluation. Efficient inference equals professional AI. Optimize like a pro. Summary. No grad context disables gradient computation for efficient inference and evaluation. Our 12th question is, how do you create tensors that require gradients? Set requires grad equals true when creating tensors or call requires grad underscore on existing tensors. Like putting a tracking device on valuable packages, now Pytorch will monitor how these tensors affect everything. Remember, requires grad equals true means track this for learning. Your learning switch. You control what learns. Master the fundamentals, master AI. Summary. Set requires grad true during creation or call requires grad underscore. Our 13th question is, what are higher order gradients? Higher order gradients are gradients of gradients, computed by calling backward on gradient tensors. Like finding the acceleration from velocity, how fast the rate of change itself is changing. Advanced calculus made simple. Remember, higher order equals gradient of gradient. Used in advanced optimization. Advanced techniques equal advanced results. You're reaching expert level. Summary. Higher order gradients compute derivatives of derivatives for advanced optimization techniques. Our 14th question is, how does Autograd handle in-place operations? In-place operations can break the computational graph. Pytorch warns or errors when this affects gradient computation. Like erasing part of your work before the teacher can grade it, the history is lost forever. Remember, avoid in-place ops during gradient computation. Create new tensors instead. Protect your computational graph. Smart coding equals successful training. Summary. Avoid in-place operations during gradient computation to preserve computational graph. Our last question is, what is the computational graph? The computational graph is a directed acyclic graph recording all operations for automatic gradient computation. Like a family tree of mathematical operations, every tensor knows its parents and children, enabling perfect backtracking. Remember, graph equals operation roadmap. Pytorch builds it automatically as you compute. You've mastered Pytorch Autograd. You're now ready to build the future of AI. Summary. Computational graph automatically records all operations enabling perfect gradient backtracking.